welcome to Rob's Fix-It Shop. So today on the bench I have this Toshiba SA-420, and I really like these Toshibas from this time. I was in high school when these guys came out, and you know, that's when I would go to the electronics store and lust after them. And so I got this one pretty affordably, and what I want to do is I want to recap it, but I want to kind of characterize how well it's working before and after the recap. And there isn't much seriously wrong with it. It looks like there's a light out on the stereo light and a couple of other things. But I thought it would be fun to do a video on trying to figure out a good way to kind of characterize what the signal looks like before and after the recap. So there's 4 different things I'm going to try to characterize the signal. One, I'm just going to use a square wave and look at it in the scope. Second, I've got a piece of software called TrueRTA, and it's able to do a sweep, and we're going to try that. I just got a new piece of software called REW, which is used to calibrate the acoustics in rooms using a microphone and then pumping out a signal. And I'm going to try to use that too to kind of look at the signal and see what I can do with that. And then lastly, I've got an HP dynamic signal analyzer, and I'm going to take a look at that and look at the signal on that. So it should be kind of interesting looking at these different ways of figuring out how well the stereo is doing, figuring out the distortion, figuring out where it's rolling off, and then see if the recap makes any difference. It's always, you know, they always seem to sound better after I'm done, but I'm wondering if there's a way that we can actually just see that. So if you're interested, hang on and we'll take a look at the 4 different methods. So before we get too far, let's take a look at the stereo. I really like how it's put together. It seems well put together. Nice power fuses, power supply. Everything seems nice and simple and straightforward. There's our amplifier board. Look at the size of that transformer. This is a 25 watt per channel stereo, and that just seems like a really big transformer for that. There's our radio section, and let's take a look at the front. Like I said, I just love the look of these Toshibas. They're just such a classic aluminum face look. And of course the case, which is around here somewhere, is all damaged, and I'm going to fix that up too. I've done a couple of Toshibas and I haven't fixed up the cases before, and so on this one I want to do that because I just think it looks so ratty when the vinyl is tearing off of that. So yeah, and then nice discrete transistors on the amplifier board, decent heatsink. Yeah, pretty cool. So let's start with simplest first. I just have my signal generator at 1 kilohertz, 1.5 volts peak to peak. Then from the signal generator it comes into the aux port of the stereo, and then I have my test panel, which I have 8 ohms or 16 ohms or speakers hooked up, and then I have my probes kind of coming onto the outputs of that. So this is just pretty much a test panel. These are the speaker leads, and it comes in, and then it also has a protection circuit in there. Anyway, I got another video on that if you want to look at that. But yeah, so we're just gonna turn up our volume and take a look at our square wave. Okay, so let's turn up our volume. And if we look at our square wave, if our stereo were perfectly flat across the response, frequency response, you would see a nice square wave here, right? But we see it kind of dipping down here, and really that's showing us is that we've got a high frequency roll off, and so that if I exaggerate the high frequency, I can square it up. So I'm just turning up the treble right now, right? And turning down, so the treble now is set at its neutral position, and there I'm turning it up. So you can see that, you know, we're rolling off as we get into the higher frequencies. And here's what it looks like when I turn down the bass or turn up the bass, right? So we can tell quite a lot from that, from this, right? So the next thing we want to do is we want to look at just do a sweep. Come to my signal generator and I say sweep and sine wave, and I'm gonna have my stop frequency at 20 kilohertz and my start frequency at 20 hertz. And then if we come over here to our scope, and let's just put on some cursors so we can kind of see it. Let's slow it down a little bit. Sweep time. So I set it to 10 seconds. So you can see that when we start out, our bass seems kind of high. Okay, now we're getting up to 16 kilohertz. Yeah, it looks like our frequency is a little bit high when we first start out. And then as we get higher, yeah, right at the beginning. So I'm going to set the starting or the stop frequency to 2 kilohertz. Right there we can really see it. Okay, so that's pretty interesting. But it does look like once it gets to about 1200, 1.2 kilohertz, then it's going to be flat for the rest of the ride. Okay, so while we got the scope going, I think what we'll do next is we'll just figure out. We'll just take 2 readings on the power output. Okay, so we have our we're putting out a sine wave here, and we're going to crank our volume until we start to clip. Now the one channel, so this channel is starting to clip right at 14.5, and the other channel clips a little tiny bit earlier. So let's see. So if we take our 14.5, square it, divide that by the ohms, and we get about 26.28 watts. So that's right about what it's advertised as. So that's good. So for the next 2 tests, we're going to got our laptop, right? I have that connected to an audio acquisition board, and that can take a microphone in or instrument in, and it can also put out right and left audio from the laptop, right? So what I'm going to do is I'm going to take the stereo and we're going to plumb it out. We're going to plumb it so this comes into our aux, right? and then we're going to take our speakers out, right? And we're going to put the speakers out through a voltage divider. And we're going to bring that into the microphone in, right? And this is just to kind of, to really attenuate the signal coming out of the speakers. And so that the software we've got then is going to produce a tone. The stereo is going to play it, and it's going to listen to the tone, and it's going to try to create a frequency response chart. All right, so here's my voltage divider, and like I say, I have it connected up to my speaker out, and then that just comes through. Once it attenuates the signal, then it just comes through, and I've got this audio board, right? USB audio board, and just got a 1/4 inch jack there coming into the microphone input, right? And then coming out of it, coming out of the back, we have our RCA jacks, and they're going to go to our aux. So we've got our output going to the aux port, we've got our input coming to the microphone, and then that's coming into our laptop here. So the thing I really wanted to show you with this is the is what's called quick sweep. What quick sweep does is it puts a tone across it does a sweep across the entire frequency range, and then plots the output. So if I come here, do quick sweep, could you hear the little blip? And so that here we're seeing that right around 200 hertz we've got kind of a peak, and then it starts to roll off as you get into the higher frequencies, and it's a logarithmic scale obviously, and yeah, so that's pretty interesting. And so like here's with the, if I turn the treble way up, and so it's kind of nice. You can really see a lot of interaction. I'll turn the bass way up. Okay, I'm going to put them both on neutral. Then I'm going to put the loudness button in. So you see, so you can see what all the different tone section is doing. So a piece of software I just recently found is called REW, and really it's to be used for checking the acoustics of rooms and using a microphone, and then going through the stereo, through the speakers, and then seeing the frequency response in that room. And but I'm using it a little bit different. I'm kind of, my hardware setup's the same as the last one, and so here we've got a signal generator that's associated with it, and then a spectrum analyzer. And there's quite a few options on the mode, and it's really a full-featured piece of software. It's free, but they do ask for a donation. But I certainly think I'm going to do that because it's really nice. And so you can let's see. Let me average it a little bit and clean it up. I don't have anything coming out. I have the tone generator set to 1 kilohertz, but then I'm going to turn up the stereo a little bit. And I'm going to turn it to my dummy load so I don't have to have that piercing frequency. And let's see here. And then here I can set my lower frequency to 20 hertz, my upper frequency to 20K, and here you can see the the spike for the 1 kilohertz, right? So it's a spectrum analyzer. Looks pretty nice. And let's then, let me just show you like I did on the other one. I change it to a square wave. And you start to see the odd harmonics coming in. So there's a lot of options in this piece of software. It's very cool. And but there's another thing you can do here. So I'm going to stop this, right? And then if you go to stepped sine measurement, you can have a start frequency of 20, 20K, frequency steps. Then when I go start, right, it's actually creating these different tones over here, and you can see the FFT moving this way across, and here it's plotting a graph of the output at those different frequencies. Here's another thing that's kind of interesting on here. It has harmonic distortion really well displayed up here, which is very cool. Yeah, so there we can see that same graph that we saw with the other piece of software, and we can see how right around 200 we're kind of peaking, and then we're rolling off as we get into the higher frequencies. And so that's really a cool way to do it, and like I say, it's very affordable. They just look for a little donation. So if I come back to here, so now I'm going to try it with the treble turned way up. And we can see our higher frequencies rolling upwards. Yeah. So yeah, it's a great piece of software. I really like it. Okay, so the last thing we're going to look at is we're going to look at this HP 35665A dynamic signal analyzer. And this thing's really fun, but it's got the ability to characterize the frequency response of a device, and so that's what we're going to do with the stereo. Chapter 3, Device Characterization. So what we're going to do is, here's the chart, right? We're going to take the source, which is the output of the signal generator, and we're going to take that, we're going to split it and return half of it back to channel 1, the other half is going to go into our stereo, and then the output of the stereo is going to come into channel 2. And then we'll be able to kind of characterize the frequency response from that. This is made for doing that. Okay, so we're just going to start kind of with our base not set up for anything, right? And so we're going to go to our inst mode and say that we're going to use 2 channels. And measurement data, we want to set our, go to frequency response, and for our source, which is the signal generator part, we want to do random noise, and then we want to turn it on, and then we not just have to turn it on, but we have to set the level. So we want the level to be 1.5, no, we want that to be probably 300 millivolts RMS, and then we're going to go to average, and we're going to turn our average on. Our number of averages are 10, and go to scale and set our auto scaling on, which is important. Okay, so let's try it out. So if we hit start, that starts our averaging, and we can see a nice response here. And what this is doing is it's pumping out random noise off here, and then it's kind of plotting the spectral response between the filter here, which is pretty great. Now if we can go to display format, we can say upper and lower, and we can see it look a little bit like it does on the other one. So we can see exactly what we're seeing on the other two screens, but with a very fancy piece of equipment. And then we can also do like Bode diagram. So I'll show you that. I want to show you how the how it's showing harmonic distortion. I just have the signal generator coming into the stereo, and then the speakers coming out to here. You got 1 kilohertz. And so you can see your peak right there. And so that we can turn on a marker function for harmonic marker, and we can also do the total harmonic distortion. And I do have to set the fundamental frequency to 1 kilohertz. And then what we can see then is we got a harmonic distortion. Let's average it. Wait a minute. Averaging on start, right? And so here we're seeing a total harmonic distortion of 0.03, which is, I think in the manual it's 0.04 that it's advertised. Our volume's kind of low now, but I'm going to turn it way up, and we'll see what that looks like then. So I turned it up to about 20 watts. And the distortion there, it's closer to 0.04. It's really close to 0.04, but that's what they advertise. Now I'm going to turn it up a little bit more into clipping. And here we see, look at, once we hit clipping, look at all the harmonics that are coming in there, and we're seeing a harmonic distortion of 1.4. So this thing's pretty cool. It's able to see that stuff. I'm going to turn this guy down. I'm not an audio engineer. I just have fun with this stuff. But so we looked at 4 different ways. Well, I looked at 4 different ways to kind of look at the signal, try to figure it out. And now I'm going to recap this guy, fix up the others, fix up some of the problems. I'll set the bias volt. I'll set the bias on it, and then let's come back and do the tests again and see if we can actually not only hear it but see the difference in the two signals. Oh, look how nice this is to work on. Look at that. So let's take a look around here. So there's, I think, the phono stage. The back of our, no, here's the back of our power amplifier. Looks a little grody there. Although it doesn't look like it's been worked on, but it does kind of look, I don't know what's going on here. Anyways, there's our power supply. One thing I'm happy to see is over here on the switch. The model of Toshiba that came out after this one had the power switch and the speaker switch all kind of together. Well, they had a different, they've got them together on the same shaft, right? But the model after this one had a different switch here, and they would always get kind of corroded. Or they were pretty bad on all three that I've owned. So, but I don't know, this is looking pretty nice to work on. All those capacitors are easily accessible from either the bottom or the top. This is kind of remarkable. Here's a little trick I use when I'm doing this, and this board's pretty easy to get to, but and I've showed this on other videos, but when I have a hard time kind of locating where a component shows up, I'll just take a little laser and I'll shine it kind of right where the component is, so like this, and then it's really easy to see. So then if I go to the top of the component, right, so we can see right away where that part is. We can see it goes right there. So there's our power supply recapped. Seems to be working. And went pretty well. This big Nichicon 4700 dual capacitor. I took it out and checked it. It's pretty good, so I'm not going to mess with it. And I was kind of missing capacitor there, so I had to use a radial one, but they looked okay. There was a couple of them that the smaller ones were not as good as the bigger ones, but none of them seemed that far off. So next I'm going to do the amplifier board. Okay, so there we're done with the recap. The tone board really does not have that many electrolytics on it. It was kind of surprising. And got a lot of these guys here. And then here we have the phono board. And I recap that. Then on the power supply board, I did not replace this guy. I didn't have the replacements for it, but it tested pretty good. The caps in general tested pretty good. It was kind of surprising. I did recap the receiver board and of course the amplifier board. That one looks pretty good. So I think next what I'll do is I'll clean the controls and see if I can figure out how to get this light bulb out. Okay, so we'll just clean these contacts, see if we can get in there. Okay, so it's time to take these knobs off, get those started cleaning. Okay, time for the knobs to go in the ultrasonic cleaner. Yeah, they turned out pretty darn nice. So I cleaned up the face, and I actually cleaned up pretty nice. There's a little bit of paint on there. Had to take a little acetone to that. It's like the stereo light is out, and I think the stereo light's on this board right here. And can I get in there? Yeah. Right down there, there's a stereo light. And so I think I can just take these screws out and pull that out. We'll see. Gotta take this whole thing out? Looks like it. Well, let's see. Let's try it. Yeah, I think we're gonna have to pull this whole face off. I don't know, it seems like kind of overkill to have to take the whole face off to just change a couple of light bulbs. Wow, that couldn't be easier. Then, let's try. So there's our stereo bulb, and they're soldered in from the back. So when I'm on a stereo station, I'm at 15 volts, so I'm gonna see how an LED would be in there. So I've got these daylight, or not daylight, but cool white LEDs, and they're right in the color range of incandescence. But look at this, these incandescents are not very bright at all. Here's the one that's burned out. And so I'm going to put this, I'm going to put the LED in here, and then I'm going to experiment with the limiting resistor to get the brightness right. Okay, so here's my two. This is where the light bulb was coming in, so I think I'm going to cut one of these traces here. Then I'm going to solder a resistor across here, and I'll put my LED through here, and I think we'll be good then. Okay, so we got the LED in there, and I've cut the trace in back, and so I just need to solder it in, and then I'll experiment with the resistor. So here it is. Yeah, it looks pretty good. It's a little bit bright compared to these, but these almost seem a little bit dim. Actually, just this one seems dim. Oh well. I think I used a 2.2K resistor on that, and yeah, I think it looks pretty nice. Also gave me a chance to clean these buttons off. Yeah, it was kind of a lot of work to put a light bulb in. Okay, so now we're going to adjust the idle, and one thing that's kind of interesting, they actually left loops on the resistor that you test across. I'm going to Put that across there. Oh, maybe not as easy as I thought. Okay, so we're all hooked up, and according to the service manual, we want to look at both sides of the resistor. This one here for the one channel, this one here for the other channel. And we want to see plus or minus 10 millivolts plus or minus 2 millivolts. Okay, so we let it warm up and we can see that we're at about 16 and a half. So let's try turning this and see what. All right, that looks pretty good. Now let's go over to the other side. I think that's about as close as we're going to get. So we weren't far off. It's looking good. Okay, time to do some testing. So, got our signal generator set up, putting out a square wave. And we look here, and it's not really changed very much. Here I can use the treble, turn up the treble and get it to square out. Right, but this is treble set at its neutral point. So, I don't know. Doesn't look good. Here's our sweep. And that does seem a little bit better. Let me change the stop frequency to 2 kilohertz. Slow it down a little. Yeah, we're still seeing it right at the beginning be up a little bit high, and then right about, yeah, does seem a little bit better though. Okay, let's try our other test. Okay, here we are set up with TrueRTA, and we're going to do our quick sweep. And yeah, it looks like it's about 2 decibels of change there. And again, we still get the big, we're right at 200 that we're seeing it kind of curve off. So this looks about the same, maybe a little bit better. I don't know. Yeah. Let's try the other one. Alright, and we want to set up a step sign measurement. And everything looks good. So we'll start. Alright, so we're seeing kind of the same behavior, kind of coming up here around 200, coming down, and yeah, it's a little harder to see the scale here, but it's about the same. And okay, well, let's go look at the dynamic signal analyzer. Alright, so there we're running. And I'm just averaging. So then if I move my cursor right to peak, right around 148, 200, just like the other one, then we drop off. Yeah, so it looks just like the other one. Anyways, I love using this thing. It's so I feel so professional. So anyway, so I thought I'd take a look at that. Okay, so let's get this set up. I'm going to scale to frequency start 20 hertz, stop 20 kilohertz, and marker to harmonic marker, total harmonic distortion, return, and here we go. And I'm going to average it too. So here I have the volume about halfway up. We're not clipping at all. And you see that total harmonic distortion is 0.01, which seems pretty good. I'm going to crank it up to clipping. Back it off just a little bit. And there you see it come up. I think it's rated at 0.04. And there you can kind of see that a little bit more. But it's right at clipping. Yeah, we've got 13.45. So that's about 22 watts there, and we're getting not very much distortion. I bet we can even bring that down by bringing the treble up a little bit. No, not much. Anyway, let me bring it up to clipping, and we'll run that again. Anyway, all right, that's it for the test.
I got 6 strings loaded.
Daddy gave a piece of land. But I have dreams of orca whales and
Well, I think that's it for this repair. I just thought it would be fun to kind of look at some different ways of characterizing the sound, and I thought it would have more of an effect than it did. I gotta admit that it sounds like $1,000,000 now. I mean, it really sounds good, and I've just been playing it down here, and it just sounds nice and rich and full, and so I don't know, and it sounded kind of dead when I first got it, so how you see that and can characterize that, I don't know. I hope it's not the placebo effect, but whatever. But I really had a good time working on this. I think it's incredibly easy to do a recap on because you have access from the bottom and from the top. All the components seem very high quality. A lot of the capacitors didn't seem bad at all. A lot of them when I'm taking out. So I think if you get your hands on one of these, I think it's really kind of fun to work on, and it cleaned up really nice. So I'm working on redoing the case, and I was going to put that in the video too, but it turns out that redoing a case like that's a lot of work. So it's up in my workshop and maybe some other time. Anyway, so thanks for coming along, and hope you had as much fun as I did just kind of taking a look at the frequency response of this stereo. All right, thanks.